Hi and welcome to another video on UiPath with me, Jeppe. This video is actually a combination of 5 videos that I've released on the Robotic Enterprise Framework from UiPath. We start by looking at an overview of the framework, then get into the 4 different states of the framework: the initialization state, the get transaction data state, the process transaction state, and the end state. And I'll try to explain each of them at a detail level that will get you through an implementation of the framework. After this video, I'm releasing a full walkthrough of an example project that uses the framework. So stay tuned and make sure you subscribe to the channel, hit the notification bell and all of that. But let's get to it. Imagine you have a development team: Jeppe, Bob, and Jill. They are each tasked with building 3 different automations based on some different business processes. So I'm tasked with building 3 automations, and so is Bob, and so is Jill. And they're all different automations. Now, the way I approach my automations, there are some similarities in how I do things from one automation to the next. They're not all the same, but I kind of know what I'm doing when I'm automating stuff. And the same goes for Bob, but he does things just a little differently than from how I do it. And Jill, well, she does things her way. And, now we have 9 different automations, and they're done in 9 different ways. And of course, each automation is different, but the approach to how these 9 are built, they are also somewhat different from one automation to the other. And that's okay as long as there are only 9 automations. But what happens is that we are tasked with more processes, and we develop those automations as well. And what happens is the business grows because we're using RPA. So of course the business grows. So Chuck and Joe join the team. And now all of us are tasked with more automations that we need to build. And all of a sudden we have a lot of automations built. And that's not a good thing if we don't know what we're doing and if we don't do things more or less the same way every time. Especially because Bob and Chuck decide to leave the team. So now we have to maintain the automations that they built. And maybe their documentation standards are not the same as ours. And maybe the way they code things is very different from how I do it or how Jill does it or Joe. So now we're really in a lot of problems. It would have been so much nicer if all of us did our automations in more or less the same way. Of course, we can't just build one automation and then copy it to all of the different business cases. But the way we approach the automation, how we load settings, how we handle exceptions, how we load data, how we process data. If we do that in a similar fashion across all of our automations, it's so much easier for me to maintain or correct errors in an automation that Jill built or Chuck built, and the same the other way around. And one way to do that is by using a template. And in UiPath Studio, there are lots of different templates for different types of projects. And for most enterprise automations, a really good option is the Robotic Enterprise Framework, also known as the ReFramework. And that's what we're going to look at now. So when you open Studio, you have the option of using one of the many templates included, and one of them is the Robotic Enterprise Framework. So we start with that. And I've actually cheated a little bit, because when we open the main workflow, we can see that the main workflow in this template is actually empty. And that's because I want to build the template with you. I'm doing that because I don't want you to get scared of the framework. It does have some complexity to it, but it's manageable and you can learn it. And once you do, you will really reap the benefits. I mean, the benefits are tremendous. So let's get into it. We'll start by drawing the different sections of the framework, and then we'll start digging a little bit deeper. So the framework is built up as a state machine, and a state machine is a type of workflow where what happens is dictated by triggers or by conditions between different states. So you move from one state to another through what are called transitions. And the first state that you sort of transition into in the Robotic Enterprise Framework is the initialization state. Inside of this state, if I double click, there's a bunch of code, and we'll go through that in another video. But what this does is it reads a configuration file and it initializes different applications that we use during this automation. So this phase or this state of the framework gets things ready for us to do some real work. Now this needs to be connected to the start node up here, and we can just do that by drawing a line from one of the connection points to a connection point here in the init state. Now the init state will start complaining because a state like this has to move on to another state until you hit what is called an end state. And we'll get to that in a few minutes. But in this first state, code is executed that reads configuration from a file. We'll go through that also later. And then starts up the applications that we need during this automation. Once those things are started, we can start to worry about data. And usually what you want to do when you automate something is you want to process some kind of data. And in order to process data, you need to first get data. And you do that in a state called get transaction data. And the get transaction data state, like the initialization state, contains a bunch of code that gets some data from whatever data source you need to process data from. And then it passes it on to the actual processing. But just like the initialization state, we need to connect the init state here and the get transaction data state with a connection. And we'll do that by drawing a line from one to the other. And this creates what I told you before is named a transition. And we'll get into transitions and their naming and stuff like that in just a few minutes. Now, if something goes wrong up here in the init state, for example, if we want to start up Excel and it doesn't even exist on the server that we're running the automation on, or if the internet connection is down so we cannot access the website that we want, maybe just some applications simply will not start for some reason, then you want to end the processing. And that's where you get to this special type of state that is called an end state. And we'll paste one in over here, and it's simply called end process. And there are two ways of ending up in this end process state. The first one, as I said, is if something catastrophic happens in the initialization state, then we simply want to move to the end state and not move any further along with our automation. Another instance where you can get to the end process state is when the get transaction data is unsuccessful in retrieving any data, because then there's nothing to process. Then you also want to move from the get transaction data state to the end process state. And again, we have a transition between the two of these, and I'll get into how and why one transition happens instead of another in just a little while. So if we assume that the get transaction data state completes successfully and actually retrieves some data for us, then we want to move into the real bread and butter of automation, which is where we process our data. So I'll paste in a process transaction state here, and that state is where we do the actual data processing. Again, I want to connect that to my get transaction data state, because once we've gotten data, we want to process it. And we do that by, again, drawing a transition here. Now, three things can happen in the processing of a transaction. Either things go well or things go not so well. And you may be thinking, well, that's only two things. Well, when not going so well, it can be either bad or really, really bad. And really, really bad is when you have a system exception. For example, if an application crashes or something like that, you lose the internet connection in the middle of the processing. Then you want to go from the process transaction state back up to the initialization state. And the reason why you want to do that is you want to retry the processing of this transaction. And we'll get into it a little bit later, but on each transaction, there is a retry count, so that you can define that a failing transaction or failed transaction should be retried, one or two or three times before finally failing or hopefully succeeding. So if something catastrophic happens in the processing of the transaction, we want to move back to the initialization state, and we want to reload all of the applications that we needed to process the transaction, assuming that one of them crashed down here. Another thing can happen, and that is you get what is called a business rule exception. And a business rule exception is simply a breach of some kind of business rule. That doesn't mean that it's a catastrophe or anything like that. It just means that for some reason, this data item cannot be processed. You can have business rules that say we can only process sales orders automatically that are below a certain amount. Well, if that rule is broken, then we don't want to process it automatically. We break the business rule, throw a business rule exception, and handle that, and maybe send an email to a person who will then handle the sales order manually. So when we experience a business rule exception, what we want to do is we want to go also to the get transaction data state, because we simply want to get the next data item that is ready for processing. And that's something I forgot to mention in the get transaction data state. You get data one item at a time, and then you process that one item. And then if it succeeds, and we can draw that in now, then you go back up and get the next item. If that succeeds, you get the next item. If that has a business rule exception, you get the next item, because we don't retry business rule exception. And if we get to the process transaction state and something really bad happens, we take this route back up to the init state, and then the applications are restarted, data is reloaded, and we try again until the retry count reaches its maximum, and then it will simply fail completely. So this is really the basics of the Robotic Enterprise Framework. You want to initialize your settings, your applications. If that fails, you simply end the process. If the initialization succeeds, you try to get some data. If you succeed in getting data, then you process the data. And you keep processing data, handling all of the errors and exceptions along the way accordingly. And once there's no more data to process, you move to the end process. And that's the end of your processing. So it's a lot to take in, but this is the basics. And this is actually what the framework template looks like if you load it up. It does have some better naming on all of these transitions, and let me explain why. On this transition right here, if we look at the properties window up here, we can see that it has two properties. It has a display name, T2, and that's the one we can see here, and it has a condition. Let's change the display name to system exception, because this is the route we take if a system exception occurs in the init state. If a system exception occurs, then we want to go to the end process. But how do we determine if that has occurred? Well, in our variables pane down here, we have a number of variables. Among these, you find a system exception and you find a business exception. And these are two variables that you set whenever a business or system exception occurs. And if something happens up here in the initialization state, you want to set the system exception variable to something other than nothing. You want to create a new instance of an exception object. So what you do is, in this transition, the other property, which is called the condition property, you set the condition for taking this route from the init state to the end state. And in this case, our condition is that the system exception variable is not nothing. So when whatever code is in this initialization state finishes, if the system exception variable is not nothing, meaning that there is a system exception, then we go to the end process state. Now, if there is no system exception, or if the system exception variable, I should say, is nothing, then we want to go to get the data in the get transaction data section. So we can type in success. Oh, if I can spell. And we can set the condition here that the system exception object is nothing. Because there are only two options. Either the system exception variable is nothing or is not nothing. And if it is nothing, we have a success. We move on to the get transaction data. If it is not nothing, then we end the process. So what happens down here in the get transaction data? Well, it's sort of similar actually to what happens up here in the init state as far as the transitions go, because we have two possible outcomes. Either we find some data or we don't find some data. And if we look in the variables again, we have this variable called transaction item, and that's the one data item that we've retrieved inside of the get transaction data state. And if that transaction item is empty, then we want to go to the end process because there's no data to process. But if it's not empty, then we want to move down into our process transaction section. So we can set these transition values. We can set the display name of this one to no more data. And we can set the condition to be transaction item is nothing. So if no transaction item was found, then we go to the end process. If data was found, that means that the transaction item is not nothing. And we can name it new transaction found. I don't remember what the actual name is in the actual framework template, but this is good enough for now. So now we have both transitions from the get transaction data sorted out. All we need to do now is we need to figure out, okay, how do we move on from the process transaction data to either get transaction data or to the initialization state? Well, we had these two variables down here, the system exception and the business exception. Well, if the system exception is not nothing, then we want to move up to the init state. So we type in, if system exception is not nothing, then this is the route we take. And we rename that to system exception. This one was the business rule exception. So we'll call this business, we'll just call it business exception. And the condition for us to take this route from process transaction to get more transaction data is that the business exception is not nothing, right? And then the final route we can take from processing to getting more data, that is if the processing of the data that we already had was actually successful. So we give it display name success, and we set the condition that business exception is nothing, and also system exception is nothing. So now we have all three possible outcomes of the processing of the transaction item that we had retrieved in the get transaction data state. And if you open the framework in your own UiPath Studio, this is what you'll see. This is the basics of the framework. You initialize your settings in your applications. If that fails, you end the automation. If it succeeds, you try to get some data. If that fails, you end the automation. If the getting of the data succeeds, you process the data. And if that succeeds, you get more data. If it fails because of a business rule exception, then you also get the next data item. And if it fails because something really, really bad happens with an application or something like that, you get a system exception and you move back to the init state and kind of start over. So let's dig into the initialization state. And inside this state, we have a few things going on. The first thing we should note is that everything is wrapped in this try-catch block. And that's because if something happens inside this whole initialization state, what we want to do if we go to the bottom here is we want in this catch block we have here, we want to catch any exception that occurs, and we want to assign the result of that exception to the system exception variable. If you remember from the first video, what determines where we go from the initialization state, whether we go to the end process or to the get transaction data state, what determines where we go is actually the content of the system exception variable. So if the system exception variable is not nothing, meaning that it contains an exception, then we go to the end process. And if it is nothing or contains no exception, we move to the get transaction data state. So everything happens inside this try catch block. And let me just expand the try part of that again. And we can see that the first thing that we do is we make sure that the system exception variable is set to nothing. So in the case that this is the second attempt to process a transaction, in case it failed with a system error, then we reset that variable. The next thing that happens is that we check if this is the first transaction we're trying to process. And we do that by checking the value of the config variable. Now the config variable should be nothing if this is the first transaction we're trying to process. And the config variable, if we look down here in the variables pane, we can see that this is a dictionary object. And what this dictionary contains are the settings for the automation, arranged in sort of a number of key value pairs. That could be a timeout with a value of 30,000 milliseconds. It could be text for a business rule exception message. It could be the URL of a website or any other kind of variable setting that you might want to employ when you're executing your automation. All of those things are saved in a configuration file, and we'll get back to that in a second. For now, we just want to make sure that the config variable is nothing. And what we want to do then is we move into this sequence called first run. And this is a sequence that's executed every time we start the automation and try to execute or process the very first transaction. Meaning this is not a retry transaction, because then the config object would be loaded already. So the first thing that happens inside the first run sequence is that we invoke this file called initallsettings.saml. That file opens the configuration file over here and then reads the contents of it into that dictionary object we saw before. And if we look at the arguments that this invoke takes, we can see that it has this one called in_config file that contains the path to our configuration file over here, That also means that you could move that file to another location, for example, a share on your network or something like that. It also contains a list of configuration sheet names. These are the names of the different sheets that are inside of the configuration file, so that it knows what sheets to read when opening the file. Also, it contains a dictionary argument, an outgoing argument, and the value of that argument, the out_config argument, is assigned to the config variable in our main workflow. So let's open this workflow and see what it does. What this does is first of all, it creates this out_config variable. It instantiates a new dictionary object and assigns it to that variable. Then it takes the list of sheets that we saw, and we can also see them down here in our arguments. Let me just, there we go. It will take the list of sheets that are in this string array, and then go through each of them, and then read the contents of that sheet, and it'll read it into a data table. And then for each row in that data table, it will check if that row is empty. If it's not empty, then it will add a new key value pair to our out_config dictionary object. So this is simply a way of reading each of the sheets in the config file and then transferring them to our dictionary object. So we get a dictionary object similar to the one I showed you before on the screen. It does one more thing, because it's also going to try to read the assets that are also stored inside of the configuration file. And that's a little bit different than reading the settings, because the stuff in the assets sheet are simply references to assets that are in your orchestrator. But the basics of how it does it is almost identical. It takes the path to the configuration file and reads the assets sheet in that configuration file, meaning our Excel workbook over here. And then for each of the rows in that data table that it creates, it will do more or less the same and write each of those rows to the out_config dictionary object. So now we have a dictionary object when we get down to the bottom of this file that contains both the settings, the constants, and the assets that are in the configuration file. Now I've made a video on specifically using the configuration file. I'll show it to you here briefly, the file, but otherwise I would recommend that you go and watch that video, and I've left a link to that in the description below, of course. So let's open that. It has a settings sheet, and in the settings it has an orchestrator queue name that is called process ABCQ. It has a name of the business process that we are automating. We could set that to some other value. In the constants, we have a number of key value pairs here that will be read into our config object. And for now, our assets sheet is actually empty. But again, go and watch the video that I made specifically on the configuration file, and that will also explain when you use settings, constants, and assets and what the differences are. So the init all settings file simply reads this Excel workbook into our dictionary object and returns that dictionary object to our main file. And then we have this config object to work with going forward. The next thing that happens is it will check if we specified the name of an orchestrator queue when setting up this automation in Orchestrator once it's done, because the whole framework template here takes one argument from the outside world, so to speak, and that is the name of an orchestrator queue. So you can actually define and change the name of the orchestrator queue when you schedule, for example, the automation in Orchestrator. Typically, I would use the configuration file for that, but you have the option, and that's what's being checked right here. If it is empty, then it will try and get the queue name from the config object. And this is actually a good example of how the config dictionary object works, because we can simply refer to the config object with the name of the value. And this orchestrator queue name, if I just quickly open the config file again, we can see that we had over here in the settings, we had an orchestrator queue name setting, and the value of that is process ABCQ. So what this automation thinks right now, because I'm not going to feed it from the outside with an orchestrator queue name, it will actually think that we're using a queue called process ABCQ or whatever it was. And when we get to the example in the final video in this series, we will of course change this queue name to the name of a queue that actually exists in Orchestrator. So the next thing that happens after we have initialized the settings, gotten the queue name from the settings or from the configuration object, is it will call this kill all processes file. And the kill all processes file is over here in the file list as well. Let me open it. And what it simply does is it allows us to kill any processes. So in here you would simply add some kill process activities for each of the applications that you will be using in your automation. And you do that just to make sure that the application is not started before you try to start it using the automation. Also, in the event that you run a transaction and the processing of the transaction fails, then it'll try to process the next transaction. And if Excel or some other application is still open from the last time you tried processing it, you don't want that. You want to shut it down and start it back up from fresh. And that's what you do inside of this kill all processes file. The next thing that happens is that this activity called add log fields is called. And that is an activity of the type add log fields. And what you do with that is you can feed it with a collection of log fields. And we can see here in the fields property, we have a collection. And if we open that collection, it right now only contains one item. And that is an item named log f underscore business process name. And to that field, we'll assign a value of one of the key value pairs in our config object, the log f underscore business process name field to be exact. And that was one of the fields that was listed in our configuration file. So that's all that activity does. You can add more fields to that if you like. And finally, inside the init state, you invoke the init all applications workflow. It's kind of the reverse of the kill all processes workflow, in that this is where you start all of the applications that you need. And what you do is you send in an argument, and let us open that. And what you send in is an argument called in_config containing a dictionary object. And guess which one? Of course, our config dictionary object. So that if you have some settings inside of your config file that you need in order to start an application, for example, and let me just open the workflow. For example, if you're opening a browser inside of this init all applications workflow, if you open a browser in here and set it to start at a certain URL, and that URL is listed inside of your configuration file, that's why it's handy for you to send in the configuration dictionary object into this file so that you can grab those values. And we'll see that in the automation that we build in the final video of the series. So that's why you send in that. But all you do in here is you just use the open application, and then you can open all of the applications you need so that they're ready when you need them later on in the automation. We'll close this again. One note before I do that though. You may wonder, why is there no try catch or anything like that inside of these init all application files and so forth. If something happens when you're trying to open, for example, a calculator or Excel or something, and the application fails to start, then whatever exception occurs in here will be propagated back to the calling file, being our main file and the invoke activity where we invoke the init all applications. And that exception, if one is sent back from the init all applications file, for example, will be caught in this catches section right here. That simply catches any generic exception, and the value of that exception is simply assigned to the system exception variable that we have. And this is where the value of the system exception variable can change and determine whether we go to the end process state or to the get transaction state. So let's take a look inside this state by double-clicking. The first thing that happens is that we have this check stop signal activity. And what that does is it checks if anyone issued a stop request inside of Orchestrator. So if someone clicked the stop button on the running job inside of Orchestrator, when the job reaches this point, it will check that stop signal. And if that stop signal has been activated, then this condition in this if statement will be met. And that will mean that we'll process this sequence here called Orchestrator stop requested, which will cause a log message to be written, and then the transaction item to be set to nothing, meaning that we go to the end process state. If nobody has clicked the stop button inside of Orchestrator, and that would be the case most of the time, then the should stop variable here will be evaluated to false, and we will go to this try catch block here, where we try and get the transaction data from a data queue. We do that by invoking another file called get transaction data, and that's one of the files over here in our framework folder. And that file is actually quite simple. It does take quite a few arguments, and let's have a look at those before we open the file. So these are the different arguments that this file takes. There's an in_transaction number, and that's basically a number that will be incremented every time we set the transaction status, and that's something we'll get to in the next video. You can also use it if you want to get a specific item out of something other than a data queue. For example, if you have a data table and you want to get the 5th item, then you can set this to whatever value you need. The in_config variable contains our configuration dictionary that we talked about in the first video. Also, I've done a specific video about the config file and the config variable, and there will be a link to that in the description below this video. The out transaction item is a variable of type queue item, and the Robotic Enterprise Framework assumes that you do use a data queue in your automations. You don't always use a data queue, I know that, but in this example we'll buy into the idea that we use a data queue, and then I'm thinking about doing a follow-up video after I'm done with the series, where I sort of take a look at some of the exceptions to the rule of how you use the framework. Please let me know in the comments if you want to see that video, and then I'll think about making it. We also have these two out_transaction field variables, and those are optional variables that are not always used. I'll show them in just a second when we get into the file what we can use them for. The out transaction ID is a string, and we'll fill that with a timestamp in this example, but you could also fill it with other stuff if you wanted to. The IO_transaction data is a variable of type data table. So this is in the event that you don't want to use a data queue. You can send in a data table with data in it, and then you can process that. It's a little bit of a different story, but we're not going to get into non-queue based processing in this video. So let's cancel out of the arguments window and open the workflow itself. In this workflow, and I'll just zoom in a little bit, this workflow is quite simple, really. It has a lot of comments, and it's worth reading these comments, because they really describe what you can do if you don't want to sort of take the beaten path of using a data queue. But what we do in the activities here is the first activity is an activity of type getQueueItem, and that simply gets a queue item from a data queue, and it needs the name of that data queue in order to proceed, and the name of the data queue is included in our config dictionary. So we can use that, and we do by default here, and that gets one data queue item and puts it inside the variable called out_transaction item. The next thing that happens is a simple if statement, and that checks if the out_transaction item variable that we just set is nothing or is not nothing. If it is not nothing, meaning there is data in the variable, then we'll just fill some of the arguments that we send back to the main process with data. And the first argument that we assign a value to is the out_transaction ID, and we simply assign a timestamp to that variable. The next one is the out transaction field 1, and then following that, the out transaction field 2. And these are simply optional fields. You could also change the name of them if you wanted to, but they are simply fields that you can fill, for example, with properties of the queue item that you just retrieved. That could be an order number, it could be an amount or something like that. And these fields you can use for logging later on when processing the queue item. And that's really all that happens inside the get transaction data XAML file. So once we have called that, we then would have a transaction item to process, and then that would cause us to move forward in our framework to the process transaction state. Now, if something was to occur inside the get transaction data state, for example, if inside the get transaction data workflow an exception occurred, because this is wrapped in a try-catch block, that exception would be caught in this catches section down here, where it logs a message of what happened. And the content of that message, we can see here again, if I just expand this a little bit, consists, among other things, of values that are stored inside of our configuration dictionary. It's really useful to use the configuration dictionary because you can really vary values of a great many things inside of your automation. So keep that in mind. After logging that message, it sets the transaction item to nothing, meaning that from now on we will proceed to the end process state and our automation will stop. And that really is what happens inside the getTransaction data state. So just to do a very quick recap, when we start our process, we go to the initialization state, and that is where we read settings from our configuration file, and we start the applications that we need in our automation. If any of those things fail, we have a system exception, and we go to the end process. If none of them fail, then we go to the getTransaction data state, where we try to get one transaction item from a data queue in Orchestrator. And if that fails, we have no transaction item, and this condition is met. Transaction item is nothing, and we go again to the end process state. If we do get a transaction item from the data queue, then this condition is met, that the transaction item is not nothing, and we go to the process transaction state. Inside of this state, a number of things happen, and this is probably one of the more complex states in the framework. As you can see, it has three possible outcomes: success, if everything goes well; business exception, if a business rule is broken; or system exception, if there's a problem, probably with an application crashing or something like that. Also, if we look over here in the project pane, we can see that inside of the framework folder, we have these workflows that do different kinds of things. But we also have out here in the root of the project, this process file. And this is where you actually automate the business process. So inside of this, as you can see in the comment, this is where you build the business side of the automation. But this file cannot stand alone. It's wrapped in this whole framework with all of the plumbing that goes along with that. And inside the process transaction state, the invoke of the process SAML file is packaged inside this try-catch block. The first thing that happens inside the try-catch block is that the business exception variable is set to nothing, much like the system exception variable is set to nothing at the beginning of the initialization state. And that's just to reset this variable so that we know that we are coming into this with a clean slate as far as business and system exceptions go. Also, we run the process SAML file itself using this invoke activity, and that takes two arguments. And that is the transaction item itself that we're trying to process, and then the configuration item that we carry around sort of in our handbag throughout the automation. So we'll cancel out, and this is what happens in the try section of this try-catch block. In the catches section, there are two catches, one that catches any business rule exception that we may raise inside the process SAML file, and an exception block that will catch any other type of exception. And all these two catches do is that they assign the raised exception to the business exception variable in the case of a business rule exception, and to the system exception variable in the case of any other exception. Finally, we have a finally block. And inside that finally block is where it gets a little bit tricky. This block calls the set transaction status SAML file, and that's another one of these helper files over here in the framework folder. And it takes a lot of arguments. And I'm going to go into a little bit of detail about this set transaction file, but the rabbit hole goes one level deeper into the file called retry current transaction, and that's when it gets even more tricky. The good news is that both the set transaction status file and the retry current transaction SAML file are typically not files that you make many modifications to if you're using an Orchestrator queue for your processing. But let's have a quick look at the arguments and then move into the file. The arguments is of course our configuration item, and of course also our transaction item, and also we'll send in a system and business exception variable in order to handle those. And then there's a number of sort of housekeeping arguments that will keep track of counts and positions and also additional logging fields, and we'll just skip those for now. If we open the file, we can see that there's sort of a decision tree structure in here, and we are trying to decide whether or not something bad happened in the process SAML file. And in the case that both the business exception variable and the system exception variable are nothing, that means nothing bad happened, and we can move into this sequence here, the status of the transaction item here, to successful. Also, we will set a number of logging fields and write a log message, but if we move back out, we can see that if one of the business exception or system exception variables are not nothing, then we move to the right in this decision. And that will take us down here where it will check whether or not it's a business exception variable that is nothing. And if it is not nothing, it will move into this block, which is handling of the business exception. And this is more or less identical to handling the successful transaction, except we set the transaction item here to failed. And another property we set is the error type, and we could have set that to application, but in this case it is a business exception, so that's what we want to do. Again, if we zoom out, and at this decision point, we discover that the business exception variable is actually nothing. That means we have a system exception, and that takes us into yet another flow. I'll get back to that in just one second. In the event that we have a successful transaction or a business rule exception, we go into this little sequence here, and all that does is a little bit of housekeeping, making sure that we increment counts and stuff so that we keep track of how many transactions have we processed. Again, if we zoom out and go into this system exception block, here we will check whether or not the transaction item is nothing and whether or not it is in fact a queue item. If it is a queue item and if it is not nothing, then we move into this if statement here that just evaluates the variable that we set up here. And then we will set the transaction status to be failed, and we will also set it to be of an application error type. We will then move on, add a couple of log fields, and we'll call this retry current transaction 7 file. And this is a file that you will most likely not ever have to change. If we open it, we can see that it basically checks whether or not the max retry number value inside of our config object is greater than 0. And if it is greater than 0, that means we don't want to have the orchestrator handle the retry mechanism. So basically a sort of a manual retry mechanism has been built here, and we don't want to use that in the event that we're using a data queue. We'll simply move to the right here, because typically when we use a data queue, this value, the max retry number inside of a configuration file, will be 0. And it'll just do a little bit of housekeeping, and then the orchestrator will handle the entire retry mechanism for us, so we don't have to think about it. But how would the orchestrator then know how many times to retry a transaction? Well, that's something you set when you create the queue in Orchestrator, and that's a topic for another video. Now, if you're not using an Orchestrator queue, then you'll most likely want to set the value of this max retry number setting in the config file to greater than 0, because then this whole left branch of this retry mechanism will kick in and handle the housekeeping of the counts and so forth for you. And you really don't have to touch anything in here, so we'll hurry back out of this and move on with that process. The final thing that happens after the retry current transaction 7 file has been run is that we will try to take a screenshot of the exception that occurred. And we'll do that by invoking the take screenshot 7 file. That takes a couple of arguments, one being the X screenshots folder path from within our configuration object, just so it knows where to save the screenshots. And if we open the workflow, we can see that it's not really that complex. It'll just take a screenshot, and then it'll do some checking that the folder exists that you want to save the screenshots to, and save the screenshot. You could also activate the recording feature in Orchestrator, and that will record not one screenshot, but a whole sequence of screenshots, so you can see not only what happened at the moment that the exception occurred, but also in the seconds leading up to the exception. I've made another video about that. I'll leave a link to that in the description for this video. Now finally, after taking the screenshot, it'll try gracefully closing the applications that we're using in order to easily be able to restart them when we loop back up to the, let me zoom out, when we loop back from the process transaction, because of the system exception occurring, we loop back to the initialization state where it'll try to reopen all of the applications and then retry whatever transaction is queued for being retried. So this is really the meat and potatoes of the entire framework. This is where the calories are, is in the process transaction, and of course in the process SAML file where you build the actual automation of your business process. Everything else is really a skeleton or a framework that wraps around this automation of a business process. And that's where the framework is really, really strong. We still have a little bit to do, and that is the end process where we close down and kill some processes. The end process state is by far the easiest or simplest of all the states in the Robotic Enterprise Framework. That means this will also be the shortest video in my series about the Robotic Enterprise Framework. So we're almost done, so stick with it, and then we can move on to the example demo project in the next video. But I'll just do a very quick recap. In the initialization state, we load settings and applications so we're ready to do some processing. We need to process data, and we get that data in the getTransaction data state. And as long as we are successful in retrieving data items, we move to the process transaction state, where we process that data either successfully or with an exception as the result. And we handle those exceptions accordingly. Now, if we run out of data, or if in the initialization state a system exception occurs, Then we move to the end process state. And this is where the execution of the automation ends. Now let's see what happens in here. First of all, I'll just collapse this, and we can see that this state is very simple compared to the other types of states. This is a state of type end state, and it only has an entry section. It doesn't have an exit section. You don't have the option of adding transitions to other states. This is all that happens is you enter this state, execute some code, and that's the end of it. And in this code, we have a try-catch block. And in the try-catch block, all we do is we try to invoke the close all applications SAML file. The close all applications SAML file is very, very simple as well. So let's open it and have a look. This is all it does. It's a sequence, and it logs a message that now we're closing applications. You can delete this activity if you want. And then it simply closes an application using the close application activity. I've added an example here that closes the notepad. And if that fails for some reason, an exception will be raised. And that will throw us back to the main workflow file, to this try-catch block, and that is where the exception will be caught. It will be caught and handled in this catches block down here, where we handle any kind of exceptions at all. In that catches block, we have another sequence that logs a message that we had some problems closing the application gracefully. And then we move on to a slightly more violent version of closing a file, and that is killing the process. We do that by invoking the kill all processes file, and if we open that, that is equally simple. It simply logs a message saying now we're killing processes, and then it uses a kill process activity to kill the process that has the name notepad. And you will need to add all of the applications that you're using in your automation to this kill all processes file, as well as to the close all applications file. And of course, in the close all applications file, you try to do things gracefully. You might need to react to a dialog that pops up when you try to close an application. Do you want to save the document, stuff like that. But if all else fails, an exception will be thrown, and in the exception block, we'll simply call the kill all processes SAML file, and that will make sure that things are killed off properly. So that is really the end process state in a nutshell. It's very simple. You can expand on it, of course, like anything else in the framework, because the framework is just what it sounds like. It's a framework, and you can expand and modify as you want to. There are some great modifications even to this framework out there, but it's important to sort of get familiar with the basics of the framework before you start exploring some more exotic options. If you haven't subscribed to my channel, do it now, because in the next video, we are going to walk through a complete demo of a very simple project that uses the Robotic Enterprise Framework. We'll load settings from the config file, we'll load data from a data queue, we'll do some simple processing, some simple error handling, but just to let you know and let you see how simple it really is to do a simple implementation of this, somewhat complex framework. But the framework has been built so that you don't have to take care of all of these trivial activities every time you want to build an automation. You can focus on what's important, and that's the business process. Don't forget to give this video a like if you liked it, of course, and you can hit the notification bell to get notified and the subscribe button to follow me on YouTube. See you in the next one. Stay safe. Thanks. Bye.